136, Standard Method for Sieve Analysis of Fine and Coarse Aggregates. This method determines the particle size distribution of fine and coarse aggregates by sieving. For this test, you will need, for fine aggregate, a balance or scale readable and accurate to 1/10 of a gram or 1/10% of the test load, whichever is greater. For coarse aggregate, or mixtures of fine and coarse aggregate, a balance or scale readable and accurate to 5/10 of a gram or 1/10% of the test load, whichever is greater. A series of sieves mounted on substantial frames to prevent loss of material during sieving. For fine aggregate, number 4, 8, 16, 30, 50, and 100 mesh sieves. For coarse aggregate, 3/8 inch, 3/4 inch, 1.5 inch, 3 inch, and 6 inch sieves. And for either set of sieves, a bottom pan and cover. A mechanical shaker that will impart a vertical or vertical and lateral motion to the sieve to sufficiently agitate the particles. The shaker effectiveness must be verified by hand sieving. And an oven of appropriate size and capable of maintaining a uniform temperature of 230 degrees Fahrenheit plus or minus 9 degrees. The sample to be tested should be obtained in accordance with ASTM D75 sampling aggregates, reduced to the size required for testing in accordance with ASTM C702, reducing field samples of aggregates to testing size, and dried to constant weight, preferably in an oven at 230 degrees Fahrenheit plus or minus 9 degrees. After drying, the fine aggregate test samples should weigh approximately 100 grams when at least 95% passes the number 8 sieve, or approximately 500 grams when at least 85% passes the number 4 sieve and more than 5% is retained on the number 8 sieve. The weight of the test sample of coarse aggregate or mixtures of fine and coarse aggregate should conform to this table of values. Weights may be from 2 to 1,100 pounds as nominal maximum aggregate size increases from 3/8 to 6 inches. The dry weight of the fine aggregate sample used in this demonstration is 535.4 grams. The procedure is as follows. Starting with a bottom pan, nest the sieves in order of increasing size of opening from bottom to top and place the sample in the top sieve. Cover the top sieve to prevent loss of particles during agitation. Agitate the sieves by hand or by mechanical apparatus. The use of the hand method is not recommended when the size of the sample is 20 kilograms or larger. To determine the amount of agitation required, continue to agitate the sieves either by hand or by mechanical means, so that after completion, not more than 1% by weight of the residue on any individual sieve will pass that sieve during 1 minute of continuous hand sieving. It is accomplished as follows. Remove each sieve in order, starting at the top, and place a pan beneath and cover on top. Be careful not to lose any of the particles retained on the sieve. Hold the individual sieve with pan and cover in a slightly inclined position in one hand. Strike the side of the sieve sharply and with an upward motion against the heel of the other hand at the rate of about 150 times per minute. Turn the sieve about 1/6 of a revolution every 25 strokes. If, after 1 minute of hand sieving, the amount of material passing the individual sieve exceeds 1%, the period of agitation was not sufficient. In determining the sufficiency of sieving for sizes larger than the number 4, limit the material on the sieve to a single layer of particles. Once the sample has been agitated sufficiently, determine the weight of the particles retained on each sieve size by weighing on a scale or balance. Remove the particles from each sieve using a stiff bristle brush for sieves 50 mesh or larger, or a soft bristle brush for sieves 100 mesh or smaller. Take care not to damage the wire cloth by too much pressure or by scraping action. It is unnecessary to remove all particles lodged in the sieve after each use. To ensure that none of the particles being removed are lost, we have placed the sieve top down in a pan large enough to accommodate the sieve. Other methods may be used. The total weight of the material after sieving should be close to the original dry sample weight. If they differ by more than 0.3% based on the original dry sample weight, the results are not acceptable. Information from the sieve analysis to be reported includes total percentage of material passing each sieve, total percentage of material retained on each sieve, percentage of material retained between consecutive sieves, and fineness modulus. The procedures and calculations needed to obtain this information are as follows. Weigh the particles retained on each sieve to the nearest 1/10 of a gram. The weights for our sample are number 4 sieve, 14.8 grams, number 8 sieve, 36.6 grams, number 16 sieve, 119.3 grams, number 30 sieve, 131.7 grams, number 50 sieve, 124.2 grams, number 100 sieve, 76.3 grams, and retained in the pan, 31.9 grams. The total weight of our sample after sieving is 534.8 grams. Next, determine the cumulative weight of particles for each sieve size. The weight of particles retained on a given sieve is cumulative in the sense that any particles retained on a sieve with a larger opening would also be retained on that sieve, and therefore regarded as retained material. The cumulative weights retained for our sample are 14.8 grams for the number 4 sieve, 51.4 grams for the number 8, 170.7 grams for the number 16, 302.4 grams for the number 30, 426.6 grams for the number 50, and 502.9 grams for the number 100. To obtain cumulative percent retained, divide the cumulative weight for each sieve by the original dry weight of the sample, 535.4 grams, and multiply by 100 to obtain percent. The cumulative percent retained for each sieve in our sample, then, is 2.8% for the number 4 sieve, 9.6% for the number 8, 31.9% for the number 16, 56.5% for the number 30, 79.7% for the number 50, and 93.9% for the number 100. Fineness modulus is an empirical number used for the acceptance and control of aggregate for concrete. It is the sum of the cumulative percent retained divided by 100. The sum of the cumulative percent retained is 274.4. Dividing by 100, the FM of our sample is 2.74. Percentage of material passing each sieve is obtained by subtracting the cumulative percent retained on each sieve from 100%. Percentage of material retained between consecutive sieves is the difference in the percentages between any two consecutive sieves. Report percentages to the nearest whole number, except if the percentage passing the number 200 sieve is less than 10%, then report it to the nearest 0.1%. Report the fineness modulus when required to the nearest 100th.